we know amazingly little about what happens beneath our feet. It is fairly remarkable to think that Ford has been building cars for longer than we have known that the Earth has a core. The distance from the surface of Earth to the center is 3,959 miles, which isn't so very far. In 1906, an Irish geologist named R.D. Oldham, while examining some seismograph readings from an earthquake in Guatemala, noticed that certain shock waves had penetrated to a point deep within the Earth and then bounced off at an angle, as if they had encountered some kind of barrier. From this he deduced that the Earth has a core. 3 years later, a Croatian seismologist named Andrija Mohorovičić was studying graphs from an earthquake in Zagreb when he noticed a similar odd deflection, but at a shallower level. He had discovered the boundary between the crust and the layer immediately below, the mantle. This zone has been known ever since as the Mohorovičić discontinuity, or MOHO for short. We were beginning to get a vague idea of the Earth's layered interior, though it really was only vague. Not until 1936 did a Danish scientist named Inge Lehmann, studying seismographs of earthquakes in New Zealand, discover that there were two cores, an inner one that we now believe to be solid, and an outer one, the one that Oldham had detected, that is thought to be liquid and the seat of magnetism. At just about the time that Lehmann was refining our basic understanding of the Earth's interior, two geologists at Caltech were devising a way to make comparisons between one earthquake and the next. They were Charles Richter and Benno Gutenberg, though the scale became known almost at once as Richter's alone. It was nothing to do with Richter. A modest fellow, he always called it the magnitude scale. The scale is, of course, more an idea than an object, an arbitrary measure of the Earth's tremblings based on surface measurements. It rises exponentially, so that a 7.3 quake is 50 times more powerful than a 6.3 earthquake, and 2,500 times more powerful than a 5.3 earthquake. The largest earthquake since the scale's invention was, depending on which source you credit, either one centered on Prince William Sound in Alaska in March 1964, which measured 9.2 on the Richter scale, or one in the Pacific Ocean off the coast of Chile in 1960, which was initially logged at 8.6 magnitude, but later revised upward by some authorities, including the United States Geological Survey, to a truly grand scale 9.5. At all events, both quakes were whopping. The 1960 quake not only caused widespread damage across coastal South America, but also set off a giant tsunami that rolled 6,000 miles across the Pacific and slapped away much of downtown Hilo, Hawaii. The San Francisco earthquake of 1906, for comparison, measured an estimated 7.8 on the Richter scale. Earthquakes are fairly common. Every day on average, somewhere in the world, there are two of magnitude 2.0 or greater. The most common types of earthquakes are those where two plates meet, as in California along the San Andreas Fault. As the plates push against each other, pressures build up until one or the other gives way. In general, the longer the interval between quakes, the greater the pent-up pressure, and thus the greater the scope for a really big jolt. Even more unnerving, because they are less well understood and capable of occurring anywhere at any time, are the rarer type of shakings known as intraplate quakes. These happen away from plate boundaries, which makes them wholly unpredictable. As far as we know, they are as random as lightning. And what causes these massive intraplate rupturings? Something deep within the Earth. More than that, we don't know. So how much do we know about what's inside the Earth? Very little. Scientists are generally agreed that the world beneath us is composed of 4 layers: rocky outer crust, a mantle of hot, viscous rock, a liquid outer core, and a solid inner core. We know that to generate our magnetic field, somewhere in the interior there must be a concentrated belt of metallic elements in a liquid state. That much is universally agreed upon. Almost everything beyond that, how the layers interact, what causes them to behave in the way they do, what they will do at any time in the future, is a matter of at least some uncertainty, and generally quite a lot of uncertainty.